Okay, so this is our semester or chapter 5 study guide, and we're going to begin with problem 1. So it says to classify this polynomial by its degree. And when you do that, we've got a highest power of 5, so it's a quintet. On number 2, it says what is the graph of y equals 1/5 x cubed? Well, 1/5 is between 0 and 1, and that's our a value, so we know this is a compression. So it's going to flatten our cubic graph. So the cubic, y equals x cubed, is in green, and when you add the 1/5 factor to it, it's going to flatten it out like the blue one. So you would have to just know to look at graphs and decide which one is a compression, right? And if there's several that look the same, then you might have to calculate some values and look at where those are at. Okay. Number 3 says write the polynomial in factored form. So they gave us, let's do this trinomial. And notice that you can factor an x out of all 3 terms. And you can also factor a 4 out of all 3 terms. So factor out the 4x first, and that leaves us with a very nice trinomial that we can plug into our magic x and get an answer for. So when you say what 2 factors of 12 add up to be -8, well, it would be -6 and -2. So there they are, x minus 6, x minus 2, and don't forget that we factored out the 4x. So this is our polynomial in factored form, 4x times x minus 6 times x minus 2. Number 4, and this is the one I gave you for your Bellwork, or did I give you 5? Did I give you this one or 5? Okay. So this one says what are the zeros of the function and graph the function. So when you look at this, you've got x times x minus 2 times x plus 5. Yay, it's already factored. So what is the zero of this? We'll set y equal to 0, and then you have to say what makes each one of these factors go to 0. Well, for x, it would be 0. And then for x minus 2, well, when x is 2, that makes that 0. And for the third one, -5. So we've got our 3 zeros of 0, 2, -5. So we'll quickly graph that, and those are our zeros of the x-axis. That's why we call them our zeros. So you're going to plot a point at 0, at 2, and at -5. Now you have to decide to graph it. Well, what's happening in between? Are they rising? Are they positive numbers? Or are they negative numbers? So you can briskly just pick a simple number to calculate. I always do, like a 1 or a -1, and those fall within our range here. So -1 is between 0 and -5. So we can plug that in and see, is it a positive value or a negative value? If it's positive, it's going to be rising. If it's negative, it will be falling. So we're just trying to figure out what's happening between our zeros so we can get a good picture of our graph. So what you want to do, I'm going to plug in a -1. See, we get -1 times -1 minus 2. That would be -3. So negative times negative, we've got a positive 3 now. And then -1 plus 5 is 4. So positive 3 times a positive 4 is a positive 12. So it's going to be positive. It's going to be way up here. So we know so far this part of our graph is going to rise. So it starts down, it goes up, and then down through the 0. Now you have to decide what happens between 0 and 2. So again, I'm just going to pick the factor 1. So we put in a 1 times 1 minus 2, so that's a -1. -1 times 1 is -1. Now we've got -1 times 1 plus 5 is 6, so it's a -6. So it's a negative number. It's falling. So now we know the shape of our graph is going to go up, down, and back up through those zeros. Okay? And that's how you graph quickly. Number 5, this was your Bellwork today. And it says, what's a cubic polynomial and function in standard form with these zeros? So they give us the zeros of -2, 5, and -2. So look, we've got a multiplicity of -2 because there's 2 of them, right? Well, what makes those? To make this a 0, it would have to come from x plus 2. So we've got an x plus 2, an x minus 5, and an x plus 2. Those three things would yield a 0 of -2, 5, and -2. And we've got a multiplicity of -2. So how do you write those? Well, just write your binomials from those zeros. So you've got a x plus 2 from our first term, x plus 5, x minus 5 from our second term, and x plus 2 from our third term. So we've got that. Now just start multiplying together. So if you FOIL these out, you get x squared minus 3x minus 10, and then multiply that trinomial times this binomial. And when you do, multiply everything by x, and then multiply everything by the 2, and then you combine your like terms, and you get x cubed minus x squared minus 16x minus 20, and that's your answer. Number 6. This is what are the zeros of the function and what are their multiplicities. So again, it's more of the same. And notice that they all share an x squared. They all share an x squared. So you can take that out first. And when you do, you're left with x squared minus 4x plus 3. Well, can you find two factors of 3 that have to be -4? Well, yes, -3 and -1. So create that, add that onto your equation. So we now have x squared times x minus 3 times x plus 1. And they're looking for the zeros of the function. So we've got them right now. We're going to have two zeros from the x squared. That's a 0 and a 0. And this term here is a 3, and this one is a 1. So we have 0, 0, 3, and 1. And our multiplicity of 2 for the 0 term. The others are a multiplicity of 1. Okay? This problem solving polynomial equations using factors. So it says what are the real or imaginary solutions for each polynomial equation. So if you notice, and this was one I got asked about a couple of times before I started digging into it, and realizing we had one little part of one of our lessons where I brought in the sum or the difference of cubics. And this is that. So if you don't remember to check for your sum or difference of cubics and to use the formula, this becomes a lot more work. Now on the test I will give you those two formulas for the sum of the cubes and the difference of the cubes. So all you have to do is recognize, oh, that's a cubic factor. What is 27x cubed? Well, it's 3 times 3 times 3 times x times x times x. Or you could rewrite that as 3x cubed, the whole thing cubed. Right, so 3 like this. Right, that means 3 cubed and x cubed, because when you have it in parentheses, you've got to do both terms in there. Right, so that's what that is. And then 125 is just 5 cubed. So we have sum of cubes here. So that makes our a value 3x and our b value 5. Then you take that and just plug it into our sum of cubes formula, which I will have for you on the cheater sheet on your test. So when you plug this in and do all your number crunching, blah, 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 you go on down, you find out at the end, we end up with something here that we're going to have to plug into the quadratic formula. Right? We can't, this we can solve. We can set 3x plus 5 equals 0 and solve that. Right? That's going to be -5/3. But on this side, there's nothing, no term that they all share. I can't factor out anything. And there's no two factors of 25 that add up to be -15. So you have to say a is equal to 9, b is -15, c is 25, and plug it into your quadratic formula. When you do all that, and I've got all the work, but you know how to do that, so remember the formula with the silly song, Pop Goes the Weasel, right? X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Don't forget that, because you're going to need it. I will not give you that formula. You should have known that in Algebra 1. So when you finally solve this with your quadratic formula, then you get x equal, well, the first one we already solved, -5/3 from this first term. And this trinomial here, using quadratic formula, we get x equals 15 plus or minus 15i rad 3 over 18. So there's your 3 answers, your 3 zeros. Okay? Now I want to remember, have you guys remember, look at your highest power. It was a 3. That means there's 3 zeros. If there was a 5 there, it would be 5 zeros. Okay, so don't forget that. Number 8 says, what are the real or imaginary solutions of the polynomial equations? So here we've got x cubed minus 8 equals 0. Now we've got the difference of cubes, because x cubed is just x times x times x. It's definitely a cube. And 8, you should, when you see the number 8, you should already be thinking that's 2 cubed. That's 2 times 2 times 2. We've done that enough where that should just be instantly clicking. If not, you need to keep working your homework. You're going to get there, I promise. So now what do we have here? Well, it was negative 8, right? So it would be negative 2 times negative 2 times negative 2. That would give us that second term. So these are cubics, but it's a difference of cubes. So for the difference of cubes, we're just going to look at our a and b value. Well, the a is x and the b is 2. Okay? Now you want to plug those into our equation that has the negative built in there, right? Remember about your signs. And you plug in your a and b and do your number crunching. And you end up with x minus 2 times a trinomial that we also have to put in the quadratic function to solve. Right? So we're going to get a 2 from this one. That's easy. So we've got one of ours, and it is cubic, so it's going to have 3. So we need 2 more. So plugging this trinomial a, b, and c into quadratic equation and solving, we're going to end up with x is equal to negative 1 plus or minus I rad 3. So there's your 3 answers right there and there. X equal 2 and x equal negative 1 plus I rad 3 and negative 1 minus I rad 3. Number 9, find the real solutions for the equation by graphing. Well, if you were to plug that in the graphing calculator, which if I were you and I had a graphing calculator in my hand, I would exactly do that. I'd go to my y equal and type in x squared plus x plus 4, hit my graph button, and take a peek. And you'll find it doesn't even touch the x-axis, so there's no solution. Remember, you've got a graphing calculator. Some things you can shortcut on, all right? And the first day we're just going through problem 14. The second day we're going to go 15 through the end, 25. So number 10 says divide 3x cubed plus x squared minus 3x minus 2 by x plus 4. So again, you can use synthetic or long polynomial division. It doesn't matter. But when you do, you get the answer. I did long, by the way. And I got 3x squared minus 11x plus 41 with the remainder of negative 166. This next problem, is it a factor? X plus 1 a factor. Remember to do that, you just do synthetic division and see if it goes in evenly. Do I have a remainder of 0? Okay, another thing you can do is just plug in the negative 1. Plug it in and see if it makes a 0. Okay, that's a way I didn't show you, but it's a shortcut. So what do? Flip the sign. Right, that's what you would have done for synthetic anyway. Flip the sign. Now instead of doing synthetic division, just plug it in. For p of x, do p of negative 1. When you plug it in, does it give me a 0? And it does. So yes, it's a factor. It says, so if it is, write p of x as a product of 2 factors. Well, we know that x plus 1 is one of the factors. So now, actually, we have to go ahead and do the work. So this is just a quick check to tell you, is it a factor, is it not? But some of you might not even want to mess with that, and you just want to go to synthetic division and see, is there a remainder? If the remainder is 0, it's a factor. If there's any other kind of remainder, then it's not a factor. Okay, but this was. So now we're going to take that factor out. So now we're going to go to, I did long division again, I think, but I didn't show it all. So in the end, we end up with negative 2x squared plus 5x minus 1. So now we've got x plus 1 times this trinomial, and that's our answer, right? Because those multiplied together yield what's underneath our division sign. Okay. Divide using synthetic division. I'm not going to go into the detail because we all did posters on these. You're experts now. So when you do, you get x squared minus 2x plus 8. 13, again, use synthetic division to find p of 4 for p of x equal this quartic polynomial. And when you divide it in, remember to flip the sign. When you've got an x minus 4, you're going to flip that negative 4 to a positive and do your synthetic division. And this is what we end up with. X cubed plus 13x squared plus 58x plus 228 with the remainder of 910. And this would be the end problem for the first day of the test. Use the rational root theorem to list all possible rational roots of the polynomial equation. So it says do not find the actual roots, right? So they give you this. Find a rational root, not the actual root, the rational roots. So how do we do this? Well, you look at your A and your C value. Actually, we called this Q and P. No, I did it backwards. The last term is P and the first term is Q. So you want to look at all the factors of P. So what do we have? We have a negative. Everything's positive, negative, so I'm just going to leave those signs off. You got positive, negative 2 and positive, negative 1. And then for the first term, 1, you just have positive, negative 1. So what are all the combinations of these of my P over Q? So it's going to be 2 over 1 and 1 over 1. So our two factors are going to be positive, negative 1 and positive, negative 2. Those are all the possible rational roots. And that was basically the easiest one of those that you could have been assigned. Right? 1 and 2. Now this is find the roots of the polynomial equation. So you want to go to the table function on your calculator and type it in x1, y1. Oh, excuse me. No. I'm backing up. Let me rewind that. This, you want to type in your y equals and hit your graph button. Okay, take a peek at it. See if you can sort of guesstimate. But what you're going to have to do is go to the table. And remember, I told you to look down the y to find a 0. And you will find 1 at negative 4 for this equation. So you know that negative 4 is a 0. That means that x plus 4 is a factor of this, right? But let's take out the negative 4 and see what's left over. So when you take out your negative 4 and you do your division, you get x squared minus 6x plus 34. And it goes evenly, so your last term is going to be a 0 because that's your remainder. Now, can we factor this? Are there two factors of 34 that add up to be negative 6? No, there's not. So you're going to have to use the quadratic formula. So a equal 1, b equal negative 6, and c equal 34. And when you plug it in, you're going to get these numbers. So for the first one, we already knew negative 4 is one of the factors. But from your quadratic formula, you're going to get 3 plus 5i and 3 minus 5i. And that's it. On 16, it says a polynomial equation with rational coefficients has the root of 5 plus radical 7 and 3 minus radical 7. Find two additional roots. Well, this is the one where you just flip the sign in front of the radical or the imaginary number. So it's going to be 5 minus radical 7 and 3 plus radical 7. There they are. So I just rewrote the original terms there and there. Rewrote it. So all you do is flip that sign and that sign. And that's your answer. Okay. So you always flip the sign in front of a radicand or an I term. That's how you do those. Okay, yeah, 17's back here. So let's look at 17. And it says find a third degree polynomial equation with rational coefficients that has the roots negative 3a. Let me delete all this. And 4 plus I. Negative 3 and 4 plus I. So we know if this is a root, that means it's a 0, right? What did it come from? It came from x plus 3 or x minus negative 3 like I show here. Right? That's just an x plus 3. That's where that came from. Now, they told us if 4 plus I is a root, and just like our last problem, then automatically 4 minus I is a root. So there's 3 roots right there. So you're going to have x minus 4 plus I and x minus 4 minus I. And notice that I kept them in parentheses. Now, clear your parentheses by distributing the negative sign to both of those terms, minus 4 minus I, and then x. This is going to be negative 4 plus I. So now we've got our terms. Now when you multiply this all out and you multiply it all together, you're just going to have to do it one at a time. You know, you could, it doesn't matter what order. I always just go down the line. I always do the first 2, and then whatever that is, then I do that. So it's up to you how you want to do it, but in the end, when you finish distributing everything and combining all your like terms, this is your answer. X cubed minus 5x squared minus 7x plus 51 equal 0. And guys, on this video, on the playback, you should be pausing, you know, and making sure you understand. I'm skipping a whole lot of number crunching. And there's the number crunching. Okay. More of it. Okay. So you can pause on the video. Now for 18, it says find all the zeros of the equation. And on this, I gave you a hint to set your table units to 0.5, and that's also on your instruction sheet. Then you can actually see the zeros, okay? But if you don't set it to half, it's never going to show, right? Because it's just going to go in those increments of whole numbers, and you need to see that it's on the halves. So I give you the hint, and I give you the hint on the calculator and on the problem. So it says find all the zeros of the equation. So set calculator to 0.5 units on the graph and your table. So you want to do it in both spots. And those are on your cheater sheet, how to do it. And then I also tell you how to set them back. So we know right away, when you graph this, it looks like it goes at 1 and 1.5. So where does that come from? A 1 and a 1.5? Well, then the binomial comes from x minus 1 and x minus 1.5. Okay? So that's your first step. So we have 2 zeros. That's our starting point. It's like a springboard to get the rest of this. So we know those are factors because they're zeros. So let's factor those out. So divide out your 1 and then divide out your 1/2. So use synthetic division, divide them out, and then whatever's left over when you divide this one out, now take out the 1.5. So that's just a straight copy down. Now divide out the 1.5, and you should have a trinomial left over, and we do. So we have 2x squared plus 50. Now just solve by solving for x. Subtract 50 from each side, divide each side by 2, and take your imaginary number out. Square root of 25 is 5, so you end up with x equal positive negative 5i. So there's our 4 answers. And remember, it was a quartic polynomial, 4th power, so there's 4 zeros to it. So they were 1, 1.5, the ones we got off the graph, and then what we divided out, what was left over, we solved 5i and negative 5i. And that's how you do those. Okay. Next, 19, we have find all the zeros of a polynomial function. So what you want to do is plug this in, again, graph it, and find your zeros. Look at your table, and you will find when you look in the y value, you'll find zeros in there. And you'll see on the graph that it's crossing 3 places. So you should go up and down, scroll up and down that table till you find those 3 zeros. Then look over at your x column. So it's a -4, a 3, and a 4. So what you want to do is take all of those out. So the 4 take out, and this is what's left over. Now take out the -4, and then that's left over, and then take out your 3. And then you're down to a very simple trinomial, x squared plus 1. Okay, so then you want to factor that out. Well, we know that that's going to be plus imaginary and plus I and negative I. So there's our 5 trinomials, excuse me. I, negative I, 4, -4, and 3. So it says use Pascal's triangle to expand your binomial. So you will have a copy of Pascal's triangle, and you would go to the 5th row, and you'll pull out 1, 5, 10, 10, 5, 1. And then start that little algorithm I told you about doing 1ab, 5ab, 10ab, plus 10ab, plus 5ab, plus 1ab. Then all of your a's, you want to start with 5, 4, 3, 2, 1, 0. And then on the b's, start with 0 and work up to 5. Then clean it up. After that, figure out, well, what is my a value? Well, it's going to be s. So replace all your a's with s. And your b is 2v. So replace all your b's with 2v and solve. And when you do, here it all is, worked out. Okay, so when you clean it all up, this is your answer. So s to the 5th plus 10sv plus 40s cubed v squared plus 80s squared v cubed plus 80sv to the 4th plus 32v to the 5th. 21, you've got use the binomial theorem to expand the binomial, and when you do that, here's your answer. D cubed minus 15d squared b plus 75db squared minus 125b cubed. 22, using polynomial functions to model data, what polynomial has a graph that passes through the given points? And again, you're going to have to do it just like we did. So put all the x values in L1 in your stat edit, and all the y values in L2, and then graph it. Take a peek at it. Then do your cubic regression. Well, actually, you'll do the linear regression, quadratic regression, and your cubic regression. Which one comes the closest? And don't forget to turn on the plots so you can match the points with the graph. And when you do, you find it's the cubic regression, and you can go to y equal and see what that was. Okay, and this one was quite easy. Same thing. 23, what is the equation y equals x cubed with the given transformation? So a vertical compression by a factor of 1/3, horizontal shift 6 units to the left, and reflection across the x-axis. So when you do all that, your vertical compression of 1/3, and over the x-axis, you put -1/3 out front. And then you're moving it 6 units to the left, so it's x minus -6, which goes to plus 6. So y equals -1/3 x plus 6. We're almost through. How many real zeros does this have? And your answer is x equal the cube of 3 plus 7. Excuse me. So, and I'll scroll down and show you the work to get that. So when you do all this, you're just solving for x. You just set it equal to 0 and solve for x. And when you do, you get one solution. But remember, they're cubic roots, not square roots. And the last problem, what is the quartic function with only the two real zeros given? So that's a 1 and a 3. So what did that come from? Well, there's the answer is x to the 4th minus 4x cubed plus 4x squared minus 4x plus 3. But how do we get it? Well, you get the two zeros, 1 and 3, so that's x minus 1 and x minus 3. Then you've got to have 4 zeros. They gave you 2. So you have to get 2 more. So we call that q of x. And we're going to make that the most simple quadratic, x squared plus 1. And then when you factor this out, excuse me, not factor it out, you're multiplying it all back together. I'm going too fast. And when you do and combine your like terms, that's what you get. So just remember, multiply by the simple quadratic of x squared plus 1, add your like terms, and that's your answer. That's everything, guys, and this was super fast. Of course, I didn't go through the fine detail, but you can go back and pause the video, work with it. If you have any questions, let me know Monday. You've got your study guide for the final. If you feel good with this, remember, we're splitting this test up into 2 days. The first half on Monday, second half on Tuesday. You can't move on to the second half if you finish early Monday. You'll just get out your study guide for your final and start studying. And then Tuesday, we'll do the second half. Okay? Thank you. Have a good day. Be safe over the weekend. See you Monday.